Good afternoon, everyone. My name is Phương Đại Ngô Liang. Today, I will present the project of Safe Roads Competition 2022. My topic will outline how to prevent fatal accidents for drivers in Toronto, Canada. Toronto is one of the most populous municipalities in North America, and significant efforts are being made across all levels of government to manage the challenges posed by increased urbanization. This case will aim to provide insights and recommendations to address some of the road safety challenges posed to Toronto. The Toronto Police Service is the first municipal police service created in North America and among one of the oldest in the English-speaking world. One key strategic area for TPS is traffic safety as it relates to public awareness and enforcement. They provided two different data sets, but in my current project, I would use mainly the acute or seriously injured data set. There will be three kinds of analysis in this project. Azure Machine Learning is used for descriptive, Power BI is for descriptive and diagnostic, Python, machine learning, and random forest are for predictive. Regarding the overall analysis, there were nearly 17,000 accidents with more than 800 fatal cases, including nearly 500 pedestrians involved and more than 700 drivers involved. So I can state that the majority of fatalities are related to drivers and then pedestrians. 2016 saw the highest fatal cases of more than 130. January, August, and September are peak months of fatal accidents. Drivers are the most common involvement type of fatal accidents in Toronto at nearly 40%, and pedestrians came at the second place at 25%. The young age groups from 20 to 39 years old, and the other one from 50 to 54, represent the highest fatality by a total of nearly 1/3. The peak hours at 6 p.m. and 8 p.m. Are the most common hours of accidents related to fatality. I would use some Azure Machine Learning and SQL techniques to conduct a basic descriptive analysis on involvement type by hour. As shown in the last slide, we can clearly see that the peak hours at 6 and 8 p.m. are the most common one related to fatal accidents. The box plot also shows that after arranging in ascending order by hours, drivers account for the most accidents at any time. Both Q1, Q2, and Q3 quarters are even higher than in others involvement types. Regarding the location analysis, Scarborough and intersections saw the greatest numbers of fatality. For example, Scarborough accounts for nearly 1/3. West Hamburg Clearview neighborhood accounts for around 3%. Intersection and at intersection area each account for around 2/3 of cases. The top fatal locations include Lawrence Avenue East in North York, Eglinton Avenue East in Credit Union Drive in North York, Kipling Avenue and West Hammer Boulevard in EY, and Lawrence Avenue East in Scarborough. Regarding the traffic condition, I can state that the normal surroundings and pedestrian collisions were the most common traffic conditions at the events of fatal accidents. But other features such as no traffic control with traffic signal, dark light, the factors contributed most to the fatality. For example, the dry road conditions account for nearly 80%. Pedestrian collisions accounts for more than half. No traffic control also accounts for more than half. Daylight and dark each accounts for around half. And no red light also accounts for most of the cases. Regarding the involvement type analysis, drivers and pedestrians got involved in fatal accidents mostly when they were at normal conditions, without alcohol, at mid-blocks. Vehicles were going ahead and turning left, and caused mostly by automobiles. Another thing to mention here is that I also use Python to conduct the statistics functions using A/B testing. So I have split it into two hypotheses. The null hypothesis states that whether light and fatality are independent without any relationship. The other hypothesis is that whether light and fatality are dependent with a relationship. And I have set the alpha at 0.05. So following X-square independence test statistics, I can conclude that we have enough evidence that there is an association between light and fatality at a 5% significance level. For the predictive analysis, I have also used Python to split the dataset into training and testing datasets. Then I built a random classification to predict the correct true fatality and non-fatality. After that, I use the feature importance node of this classification method to print out the most important features, including aggressive driving yes, pedestrian, and light dark. I will apply the aggressive driving yes to the agnostic analysis. We can see that the random forest was proven with better classification on training and testing sets and had higher accuracy and geometric mean with more correct true positive and true negative. So regarding the diagnostic analysis, we can state that aggressive drivers are one of the key features resulted from the machine learning random forest. This feature accounts for most of the young age groups of drivers going ahead under normal condition, but exceeding speed limit and losing control while there was either traffic signal or not. No red light in daylight with clear visibility in all districts. Now I will mention the top 4 of places related to the fatality. The first one is the Lawrence Avenue East in North York. So you can see that there was a very small turning bright signal with no clear big signs along the curve of the right path. For the Eglinton Avenue East and Credit Union Drive, drivers tend to going ahead while driving properly or exceeding speed limit while they got drunken. There was no speed bump, no speed limit sign before a narrow road ahead. The Kipling Avenue and West Humber Boulevard saw that fences blocked the vision of incoming vehicles for the ones on this side that were about to turn right. The Lawrence Avenue East in Scarborough saw that most of the drivers going ahead or stopping while driving properly or losing control. There was no clear lines drawn at the intersection. So I can conclude that the aggressive drivers, Scarborough, dark light, young age groups, peak hours, going ahead maneuver, no traffic control, no red light, blocked vision, no speed limit control are the main direct factors causing fatal accidents related to drivers. Here are some of my recommendations. Clear and light reflective signs would be useful for drivers from far away and visible at night. Turning left lanes make clear direction for cars waiting, or on the correct lanes to make left turn. Rumble strip will be effective and not cause too much delay of speed. Modern speed limit signs can change depending on conditions. That is all of my presentation. Thank you for listening and stay safe.